Alright guys, this video is for those who were not able to make it to class today. This is us going over Light Lab 4, which we've been participating in for the last couple of days. And before we even start talking about the lab, what I want you to think about is kind of the question that we began the unit with was, why don't the stars light up the sky at night like the sun does during the day? Even though we have all these suns that are bigger and brighter than our current sun, why don't they light up the sky? Why does it look, like this? Why do we have this type of a sky at night and not these big bright stars that end up lighting up the sky? And what we saw from the lab was that light spreads out, right? We saw that light kind of came from a source. It comes from here, and as it travels, it spreads out. Now, the two things I want you to take notice of two things about the light as it moves away from the source. We have one thing that we notice real easily is that obviously the light is a lot brighter here. The light is super bright here, and it's not so bright over here. So we lose some brightness out of our light as it goes from the point of origin to the point of reflection. We also notice the area that the light takes up. It's very small over here, but over here, it's very large. So we go from small to large and bright to dim. Okay, two really important things to understand about light spreading out and light moving from one place to another. Now, this is what we call the inverse square law, and here's just a couple of pictures to help emphasize this, but the inverse square law is the intensity of light. It's all about the intensity of light. The intensity of light is inversely proportional to the distance away from light. So give me a couple of seconds and I'll explain that. That's a very complicated definition, but I want you to take notice of how we have this light, and this is kind of like the flashlight example that we just looked at. It spreads out. It definitely gets dimmer over here. It covers a much larger area. It's much smaller and concentrated over here. But light always doesn't come from a source that just points it in one direction. We also have the sun, which has light in a concentrated circle or sphere. But that light goes out in all directions. So when we imagine light leaving from something like the sun, I want you to imagine that it's a sphere ever expanding. It's obviously brighter in here and dimmer out here. It's covering a smaller area in here and a larger area out here. Just like we see over here, it's doing the same exact thing. Okay, let's continue. Now the inverse square law, now this is the data that we recorded during the lab. All right, we had it set up so that we took these measurements. When we moved the light 10 centimeters, 20 centimeters, 30 centimeters, 40 centimeters, 50 centimeters away from the reflective surface, we got these answers right here as our number of squares that were illuminated. So we can definitely see that as we increase distance away, we are increasing the area that it's covered. So here's where the square comes in. Notice how we have a 5, 50, 40, 30, 20, 10. If you take that first number, 2 squared equals 4. Let me pick a different color. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. And 5 squared equals 25. All right, now let's continue talking about the brightness. Now this is where the inverse comes in, because as we have this number right here, we figured out the area illuminated, the brightness is now the inverse. So all the inverse means is that if we have 4, it's the inverse of 4, which is 1 over 4. If we have 9, the brightness is going to be the inverse of 9, which is 1 over 9. 16, same idea, 1 over 16. So the brightness and the area illuminated are proportional by the inverse. So in summary, why do stars appear to be so dim when they're so far away? Even if we have these giant stars, here's our little sun, but we have these ones that are bigger and more bright, but they don't light up the sky like our sun does. They look more like this in the nighttime sky. Why is that? Because we have the inverse square law right here. This inverse square law answers that all. All right, let me know if you guys have any